entering what industry insiders are calling the agentic era of DevOps.
It's a massive shift. I mean, it's completely rewriting the rules.
It really is. So our mission today, with the stack of sources we're diving into, we've got playbooks from Fairwinds and Portworx, deep analyses of top tools like GitHub, GitLab, and various MLOps platforms.
All the heavy hitters.
Yeah, all the big ones. We want to give you, the listener, a comprehensive map of how AI is fundamentally ripping up the traditional software development lifecycle. And, give you some actionable advice on how to survive this shift. So, okay, let's unpack this. Where do we even start?
Well, the magnitude of this transition really comes into focus when you look at where the automation is actually happening.
Right.
10 years ago, the whole DevOps movement was fixated on automating the right side of the software pipeline.
The delivery mechanism.
Exactly. Everything from the moment a developer commits the code through testing to deployment. But today, in 2026, AI is automating the left side of that pipeline.
Wait, so from the raw idea to the working code?
Yes,
Wow.
the actual creation and architectural logic. From a raw Jira ticket directly to functional code. It's a shift from human-scripted automation to what we call autonomous agency.
Autonomous agency. That sounds, it sounds like sci-fi, but we're doing this today.
We are. We're no longer dealing with a machine blindly running a Python script. Large language models, LLMs, they're acting as primary executors now.
With actual decision-making authority.
Right. They evaluate a problem, test solutions, iterate, and the gap between teams adopting this and those who aren't is widening fast.
Like the early DevOps adopters who suddenly deployed 200 times more often.
Exactly, that kind of leap. One of our 2026 reports highlights this incredible benchmark. Anthropic built a desktop agent, Claude Cowork, using a 4-person team in just 10 days.
Oh, wow. 10 days. For a project of that complexity, that would traditionally take, a massive engineering org and months of sprint cycles?
Easily. And the only way a 4-person team pulls that off is because they weren't actually writing the application.
We were orchestrating it.
Right. The role of the senior engineer has completely detached from, typing speed or remembering syntax.
It reminds me of the shift to infrastructure as code, like how we stopped manually configuring servers and started using Terraform.
That's a great analogy.
We stopped saying, take this road, turn left here, and just gave the system a GPS destination. So we're doing that with software development now.
Exactly. You define the behavioral constraints, set up the API contracts, and the humans act as the architects. The AI agents operate as this high-speed assembly line.
Which means we really need to look at the machines on that assembly line. Because there's a huge arms race right now, right?
Yeah.
Between GitHub Copilot and GitLab Duo.
Oh, it's massive. And we have to be clear, the capabilities have moved so far past simple text autocompletion.
Right, we aren't just hitting tab to finish a for loop anymore.
Not even close. GitHub integrated OpenAI's GPT-5 back in August 2025, and their Copilot coding agent is basically functioning as a fully autonomous developer.
And the speeds are crazy, right?
Unbelievable. We're talking best-in-class inline completion speeds of 0.3 to 0.8 seconds. But the workflow is where it gets crazy. This agent can assign itself an issue, write the code, run local tests, parse the stack trace if it fails, fix its own code, and then open a pull request.
Completely solo.
Completely solo.
Okay, here's where it gets really interesting, though. Letting an AI loose on your code base, and especially your deployment pipelines, sounds frankly terrifying.
It does. A lot of people feel that way.
Like, what if it hallucinates a YAML configuration? If an agent doesn't have the broader context of the system, couldn't it push a fix that passes local tests but just absolutely nukes the production database?
Yeah, and that contextual blind spot is exactly what early AI tools suffered from. It's the specific problem GitLab Duo was engineered to solve.
Okay, how do they solve it?
Well, GitLab takes a platform-native approach. They use something called multi-file contextual processing.
Multi-file. So it's looking at more than just the snippet it's working on.
Right. Instead of looking at a fragmented piece of code and just guessing, the Duo agent analyzes the full content of a merge request simultaneously.
Wait, how does it process an entire enterprise code base without blowing up the context window of the LLM?
Good question. It doesn't load the raw text of the entire code base. It actually generates a semantic graph.
Oh, interesting.
Yeah, it maps out how a change in your database schema natively cascades into your API routing and your front-end components.
So it understands the blast radius before it writes the code.
Exactly. And this is why the sources point out a clear verdict. GitHub is currently winning the solo developer and startup space because of its ecosystem and speed.
Right, makes sense.
But GitLab is dominating the complex, deeply intertwined enterprise CI/CD market.
Because of that blast radius awareness. Okay, so we've got these agents writing code, opening PRs, but if they're generating thousands of lines in seconds, humans can't review that fast. If an AI breaks the code, how are we practically applying AI to fix it safely?
Well, you have to build safety constraints directly into the automated workflow. The reports detail a really great real-world CI/CD use case for this.
Let's hear it.
Say a critical production deployment pipeline fails overnight. Engineering is blocked. In an agentic workflow, the AI agent automatically analyzes the pipeline logs.
Like thousands of lines of logs.
Instantly, and it spots, say, a missing AAA mental reference.
But it doesn't just blindly push a fix to production, right? Because of the hallucination risk.
Exactly. It updates the YAML, and then it initiates a validation build, a dry run in an ephemeral, isolated environment.
To mathematically prove it works.
Yes. Without touching production, only after validation does it open a pull request. So a 45-minute catastrophic outage turns into a 5-minute code review over morning coffee.
That's incredible. And they're optimizing pipelines too, right? Analyzing the package lock.json to maximize cache hit ratios.
Yeah, but they design caching strategies and manage complex matrix testing with fail-fast logic. It eliminates so much compute waste.
And we have to talk about this. This speed introduces a huge security dilemma.
It really does.
The sources say 45% of organizations report production incidents tied to AI-generated code, and almost half expect AI to increase vulnerabilities.
Right, because traditional static analysis tools like SAS2, they just fail here. They generate too much noise, they flag every theoretical vulnerability and bring the high-speed pipeline to a grinding halt.
So security has to evolve from being a blocker to an accelerator.
Exactly. And tools like Checkmarks and Wiz are doing this with reachability-based detection.
Reachability-based, meaning what exactly?
It means they aren't just scanning a library for a known CVE, they map the execution path of the application. If a vulnerable library is imported, but your code never actually invokes the vulnerable function.
The AI knows the vulnerability is unreachable.
Right. So it deprioritizes the alert. Plus, they use predictive risk scoring. They analyze over 220 different parameters, exploit maturity, network exposure, running state, to rank vulnerabilities by true exploitability.
And when a real reachable CVE is found,
the AI generates the fix, validates it, and opens a merge request instantly.
So if the AI breaks the code, but another AI is there to scan it and patch it, are we basically just creating a closed loop of bots talking to bots?
We absolutely are. That bot-to-bot loop is exactly what's happening. But it extends way beyond just the code. It's happening at the infrastructure level, too.
Which brings us to Kubernetes, the operational control plane.
Right, because to support this massive scale of AI-generated code and machine learning workloads, your infrastructure has to be self-managing.
You can't manually provision servers fast enough for AI speeds.
No way. Kubernetes in 2026 is the strategic backbone for managing these resource-intensive GPU workloads. And mature platforms today, they treat self-healing as a defining characteristic, not an afterthought.
The Fairwinds playbook mentioned something interesting about this, that true self-healing isn't just bolting an AI chatbot onto a broken alerting system.
Yeah, that's a crucial point. You have to standardize your cluster's health signals first.
So, meaning the telemetry data, the logs, metrics, traces, they all have to be formatted so the autonomous control layer can read them without a human translating.
Exactly. And once that telemetry is standardized, predictive autoscaling takes over. Platforms like Sedai and Cast AI, they provide autonomous control layers that actually analyze the live signals to scale pods and nodes ahead of demand.
Ahead of demand, so it's moving from reactive to predictive operations.
Right. It doesn't wait for the CPU to hit 90%. It predicts the spike and scales up before the users even arrive.
And for inevitable failures, we have AI ops, right? Level 0 automation.
Yes. Tools like Moogsoft, Big Panda, Dynatrace, they identify recurring failures, like an out-of-memory event.
And instead of a pager waking you up at 3 a.m. because a server died,
the AIOps platform automatically executes a playbook. It restarts the service, clears the queues, and drastically reduces the mean time to repair.
I love this shift. So the infrastructure notices it's getting sick, takes its own medicine, and just leaves you a note about it in the morning.
That's exactly it. But we also have to factor in data management. Solutions like Portworx are critical here to unify container data management.
Because if your stateful data drifts across regions, what happens?
Your AI models start operating on conflicting truths. And that leads directly to model hallucinations. So highly available, synchronized data is vital.
Okay, so managing infrastructure is half the battle. But if your infrastructure is running AI, how do you manage the life cycle of the AI models themselves? Because that's an entirely different operational discipline, right?
Completely. And this is where the evolution of machine learning operations, or MLOps, comes in.
Let's talk about the difference between MLOps in, say, 2023 versus today in 2026.
Sure. So in 2023, MLOps was really just automating ML pipelines. The models were basically just predictors. You feed them data, they make a prediction.
Right.
But in 2026, AI systems have shifted from being mere predictors to being actors.
Right, because they're utilizing argue systems, retrieval augmented generation.
Exactly. They are pulling real-time data from vector stores, making decisions, and acting on them dynamically.
And managing those non-deterministic actors requires serious tools.
The top MLOps tools today: Databricks, Mosaic AI, MLflow 3.x, Kubeflow, Weights and Biases, they act as the operational backbone. They provide full lifecycle governance, real-time drift detection, and most importantly, trace-level observability.
Trace-level observability. Because that's the thing, right? How do you diagnose a black box neural network? If an agent deletes a staging environment, how do we know why it did that?
Well, this is why a new subfield called Agentops was born. Agentops platforms sit on top of the MLOps layer. They inject trace IDs into the LLM prompts.
So it forces the agent to log its chain of thought at every single step.
Exactly. It makes the black box observable. Agentops oversees their behavioral management, their reasoning, and provides automated diagnostics for recurring errors.
So if I'm listening to this right now and I'm thinking, my team is still struggling to deploy once a month, how do I even start with Agentops?
Yeah.
What is the practical first step for a DevOps engineer today?
The very first step is a mindset flip. You have to move away from I write and the AI assists to the AI drafts and I review.
Treat the AI as an automation tool that needs strict constraints.
Right. And you leverage something called the information advantage.
Let's break that down because the sources highlight this heavily.
So traditionally, you might spend 3 days manually building one architectural pattern just to see if it works.
And if it fails, you just burned 3 days.
Exactly. But now you spin up 3 coding agents, give them different constraints, and have them build 3 different options in a few hours.
You evaluate them side by side and just pick the best one.
You gain a massive information advantage without spending the manual hours.
But that means humans have to front load the work, don't they?
Yes. Because AI speeds up the execution so much, you have to spend your time on alignment. Writing crystal clear product requirements, documents, defining edge cases, and setting up strict quality gates.
So what does this all mean for you, the listener? It means your value is no longer tied to how fast you can type boilerplate code. Your value is your judgment.
Spot on. The pipeline has fundamentally changed from manual typing to orchestrating brilliant autonomous systems.
From the contextual awareness of GitLab Duo to the predictive auto-scaling of Kubernetes, all the way to Agentops.
It's an entirely new world. And I'd love to leave you with one final thought to mull over regarding this shift.
Let's hear it.
We've established that AI agents are now writing the code, scanning it for security, deploying it, and even healing the infrastructure when it breaks. So looking ahead, will the future DevOps engineer look more like a software developer or more like a human resources manager for digital employees?
Oh, wow. That is a brilliant framework. An HR manager for digital employees. Well, we designed this deep dive specifically for you to help you cut through the noise and understand the mechanics of this massive shift.
The tools are out there, you just have to start orchestrating them.
Exactly. The roads have changed, the vehicles are driving themselves, but someone still has to punch in the coordinates. Keep exploring the tools, stay curious about the mechanics, and lean into the automation. Catch you next time.